So, a new way to find the area of a triangle. Now, I mean, your mind should sort of be spinning because there are a multitude of ways that we have now learned how to find the area of a triangle. Geometry okay, elementary school, 1/2 base times height. Last year in geometry, you did 1/2 perimeter times apothem. Earlier in the year, we used matrices to find the area of a triangle. Then last week, we learned about what to do in a side angle side situation to find the area of a triangle. And today we're going to look at what happens in a situation when we are given side, side, side. When we are given side, 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 we use what is called Heron's area formula to find the area of a triangle. Now, the area using Heron's area formula is equal to the big old square root of S times the quantity of S minus A times the quantity of S subtract B times the quantity of S subtract C. Now, you should be wondering, most of us, I'm thinking, are realizing that little a, little b, little c are the sides of my triangle, but we should be wondering what in the world is S. First of all, it should bug you that they used S as a variable at all. That would drive me nuts. And the second thing I would be wondering is why or what is S? Well, the reason that they used S is because S is what we call the semi-perimeter. The S is the half perimeter. So in other words, in order to find S, we take half of the perimeter. 1/2 of the A plus the B plus the C. So Heron's area formula, nice, sweet way to find the area of a triangle. If I know the 3 sides of my triangle, this is by far the fastest way to find it. No doubt about it. So if I'm finding the area of this triangle, notice that I'm given side, side, side. I have side, 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 so I'm going to use Heron's area formula, S times the quantity of S minus A, times the quantity of S minus B, times the quantity of S minus C. Now, first thing I want to do is find S. Well, S is 1/2 of the perimeter, so 1/2 of 17 plus 12 plus 14. All right, so S is equal to, all right, what do we get for that? 1/2 of 17 plus 12 plus 14. 21.5, absolutely. I get 1/2 of 43. So S is 21.5. Typically, I don't like decimals, but with Heron's area formula, it's going to be impossible to avoid them. So, to find the area, I take the big old square root of. My process is the same every time. It's the big old square root of that semi-perimeter, 21.5, multiplied by the 21.5, subtract my first side of 17, times my 21.5, subtract my second side of 12, multiplied by my 21.5, subtract my last side of 14. So the area is equal to the big old square root of 21.5 times, well, 21.5 take away 17 is going to be 4.5. 21.5 take away 12 is going to be 9.5. And then 21.5 take away 14 is going to be 7.5. All right, what do I get underneath that square root? What do I get underneath that square root? Somebody got it? What do I get under that square root? What'd you get? 6,893.4375. I love it. Yep. Now, that is not the area though, because what do I need to do with that yet? All right. So what do we get approximately for the area after I take the square root of that?
83.03.
All right. About 83, and let's call it square units because I do not know if I'm in feet, inches, centimeters, meters, miles, what? Love it?
Love it.
Questions? Really pretty straightforward. As long as you remember the formula and you remember the process, you should be okay. Any questions? All right.